might come across this in your forthcoming exam. Here is exactly how to crack it. This is a sample from Soundwave. The frequency of a plucked string is 800 hertz. Frequency was given to be 800 hertz. When the tension is 8 newtons. Calculate first the frequency when the tension is reduced to one fourth of its original value, and secondly, question number 2, tension required to produce a note of frequency 600 hertz. Now, the first thing we'll do here, we need to understand the relationship between frequency and tension. And so the relationship that exists between frequency and tension is that frequency equals k square root of t. And so this is the relationship that exists between them. And now note, from the question we're given frequency and we're also given tension, so we need to solve for k. And in solving for k, would make k the subject of formula. It becomes f equals k square root of t over the square root of t over the square root of t. And so this cancels this, and we'll be left with k equals f over the square root of t. F over the square root of t. Now, whenever you have square root as your denominator, would make use of something called surd. Would use a concept called surd, and the part of surd we make use of is called rationalization. So we are going to rationalize this, and to rationalize this becomes, we will write it as the square root of t over the square root of t. So in order to get k, it becomes f root t over root t times root t. So this right here is what would the formula would use to get our value of k. And so next we'll plug in our data. So k equals, our f was given to be 800. The root of t is square root of 8 over the square root of 8 times the square root of 8. Now, what will happen here is that would 800 times root 8 is 800 times root 8, while the square root of root 8, if you punch your calculator, square root of root 8 times square root of root 8 will get the square root of 64. Square root of 64. So I'm just going to take it up a little, and we'll continue. And so k equals 800 root 8 over the square root of 64 is 8, so we'll put here as 8. Now, what can go again? 8 can go into 800, so 8 here, 8 into 800, you get 100, and so this become 100 root 8, and this will be our value for k. So the value for k is 800. I would like to write it. K is 100 root 8. This is our value for k. 100 root 8. Now, I want to scroll back and see our first question. Now we need to solve for the first question. Now we can solve for the first question since we've gotten k. Do not forget, our k now is 100 root 8. The Roman figure I says the frequency when the tension is reduced to 1/4 of its original value. So the frequency the frequency when the tension is reduced to 1/4 of its original value. So the frequency, solve for frequency when the tension equals 1/4 of its original value. And do not forget the original value of the tension that was given is 8 newtons. So I'm just going to plug this in to become 8/4 and we'll get 2. So it's the tension we would use here is 2 newtons. And the first established relationship is F, do not forget, equals K root T. And so we asked to calculate for the frequency. So we just need to plug in our data next. Plug in your data. F equals K is 100 root 8 times 100 root 8 times the square root of 2, which is these 2 newtons here now, the square root of 2. And so we could write this as 100 root, since square root of 8 and square root of 2, they are both on 2 and 8, they are both under square root. We could multiply the both of them and put them under a single square root. So 2 times 8 is 16, and this would be 100. The square root of 16 is actually what is 4 times 4, and our frequency would be 400 hertz. The frequency will be 400 hertz. That's the Roman figure I. Our answer is 400 hertz. Next, the next question, which is the Roman figure I. Let me indicate it here. I. We have to solve for the tension, right? Let's go back. Roman figure II. The tension required to produce a note of frequency 600 hertz. So the tension required to produce a note of frequency 600 hertz. You are supposed to solve for tension, whilst the frequency that was given to us here is 600 hertz. Do not forget the value of your K that has been given. K, we'll solve for K rather, 100 root 8, right? And so what will happen next is we'll plug in, making use of F equals K root T. This is the relation. We are asked to solve for our tension here. So what we'll do, I would just want to plug in the data now. Frequency is 600, right? 600 equals our K, do not forget, is 100 root 8 times root T. And so what we'll do next is we divide all through. In order to isolate the root T, we divide all through by 100 root 8 over 100 root 8. This would cancel this here. I will be left with root T equals 600 over 100 root 8. Now, what could go? 100 here is 1. 100 into 600 is 6. So, the square root of T equals 6 over root 8. 6 over root 8. And next, we'll do with square both sides. Sorry, would square both sides. In order to remove the square root from your t, and this will be written as the square root of t in brackets raised to the power of 2 equals 6. The square root, if it cross to the other side, it becomes raised to the power of 2 for 6 over, you have square root of 8 raised to the power of 2. And going further, this would cancel this, and we have t equals 6 raised to the power of 2 is the same thing as 6 times 6 over the square root of 8 times the square root of 8 would give you the square root of 68. Square root of 64. And this would be 6 times 6 is 36. The square root of 64 is 8. And so 8 into 36, 8 here is 1, 8 here is 4.5, right? 4.5. So your final answer is 4.5 newtons. So our tension is gotten to be 4.5 newtons. Would you like to solve? And that's all. So the first we solve for our k, which is 100 root 8. Next we solve for the Roman figure I. We are asked to solve for frequency, and we got 400 hertz. And Roman figure II, we are asked to solve for the tension, and the value of the tension is 4.5 newtons. Would you like to solve similar questions as this? Click on the link in the description box. You win. Just believe.